Hi everyone, this is Math Done Right with a college algebra or algebra 2 video on solving linear equations. So first of all, it'd probably be helpful if we know what a linear equation is. So a linear equation is any equation of the form ax plus b equals 0, and that's where a and b are real numbers, and x is the variable. So the whole goal behind solving linear equations is solving for x essentially. So x is the variable or the unknown here, a and b are just real numbers. So we want to solve for x. Right, that's what we want to do. But how do we do that? Well, there's three kind of general steps we can do in order to solve for x. The first one is we're going to multiply and distribute whenever we can. So let's say when possible. Step number two is we're going to gather like terms. Now, what I mean by like terms is I want to, on the same side of whatever equal sign we're looking at, like the left or the right side, I want to get all my x's with my x's, all my numbers with my numbers. Try to combine those when I can. And then the third step is going to be solve for x. Right? That's the goal. So we're going to, add or subtract on both sides of the equal sign in order to do that. So we have a quick note. So linear equations can have three types of solutions. So there could be one unique solution. There could be no solutions. Or there could be infinitely many solutions. Now, if we go back to the little header I made, I didn't quite complete it, but I can do that right now. So if I have one unique solution, I'm going to have two lines intersecting at one spot. And this is my solution, the intersection between these two lines. And now let's say I have two parallel lines. Notice they never cross each other, so I have zero solutions there, no solutions. Now, this one is kind of the weirdest one. Let's say the orange and the blue line are right on top of each other. They coincide. We call these lines coincident because they coincide with each other. This gives me infinitely many solutions to the equation. All right, now let's look at some examples. All right, so example one. Let's like make that look more like a 1. So let's look at 5 times 3x minus 1 plus 2x minus 4 equals x minus 10. Okay, so what's step 1? We want to multiply or distribute when possible. Okay, well I have this 5 and then this stuff inside parentheses here, so I have to distribute this 5 to both of these terms, right? So when I do that, I have 5 times 3x gives me a 15x. 5 times negative 1 gives me a minus 5. And there's no more distribution or multiplying here, so everything just gets copied down to the next line. And I'm left with this equation right here. Now the second step says to gather like terms. So I'm going to combine my x's with my x's. And so I have 15x plus 2x gives me a 17x. And now I'm going to combine my numbers. I have a minus 5 and a minus 4 to give me a minus 9. And I do this on both sides of the equation, but the right hand side's already taken care of because there's just one x and one number. So we just copy that down again. Now what I'm going to do is I'm going to first subtract x from both sides. And this gives me 17x minus 1x. There's 16x's left over. Minus 9 equals minus 10. Now I'm going to add 9 to both sides. And that's going to give me 16x equals negative 1. And to finish this out, I'm going to copy it down over here. So to finish this out, I'm just going to divide both sides by 16. And that gives me that x is negative 1 over 16. Now I got only one answer, so this is the case where I have one unique solution. And we can always check this by just taking this x value and plugging it into my original equation. Wherever I see an x, I replace it with negative 1 over 16, and I should get the same number on both sides of the equal sign. And I'll let you guys check that at home if you want. It's a good practice, you know, with these types of things. If you can check the answer, you might as well, right? Because you could have made some kind of mistake in here. So it's a good practice just to check it whenever you can. All right, let's look at another example. All right, example 2. So let's look at negative 3x minus 5 equals 7 minus 3x in parentheses plus 2. All right, so the left-hand side, I don't have to worry about multiplying or distributing anything, but on the right-hand side I do. I have this minus sign sitting out front, so I have to distribute the minus to both of these on the inside. Okay, so the left-hand side stays the same. Now I have a minus 3x and a minus 2. All right, now I'm going to gather like terms. The left-hand side is already done. The right-hand side, I have a 7 and a minus 2. Right, so those are my two numbers that I'm going to add to give me 5, and then I have minus 3x. Now I'm going to add 3x to both sides. Okay, so these cancel each other out, and then on this side they also cancel each other out, right? We see that negative 3x plus 3x is 0. And so what am I left with is minus 5 equals 5. I'm going to put a question mark over that. What does that mean? I have minus 5 equals 5. Is that ever true? Is this true? The answer is no. Negative 5 is never equal to positive 5. So what does this mean in terms of my problem? In terms of solutions, it means there's no solutions. Three exclamation points. Let's underline it too. So we know there's no solutions. And when I say no solutions, that means there's no number that makes this equation satisfied. Any x value you put in here, you'll get two things that are not equal to each other on both sides of the equal sign. All right, so now I had a problem with a unique solution, no solution. Probably going to give you one with infinitely many solutions, for example number 3. All right, so let's look at example number 3. All right, so we got, let's look at 2x plus 10 equals 2 times x plus 5. We want to multiply and distribute. Okay, left-hand side's good to go. Right-hand side, I got to distribute this 2 inside of here. All right, so I get a 2x plus 10 equals 2 times x gives me 2x. 2 times 5 gives me a plus 10. If I subtract 2x from both sides, these cancel, and I get 10 equals 10. Yeah, that's always true. And so when I get something like one number equals another number, or it equals the same number. This means I have infinitely many solutions. Infinitely many solutions. 3 exclamation points in the next line because I ran out of room. Okay, so this means I could take any x value I want and it'll satisfy this equation right here. All right, so now let's look at some examples that are a little bit harder. Take a little bit more work. All right, so I have 2 more examples. Let's call this one example number 4 because that's what comes after 3. So I've got x plus 2 times x minus 1 equal to x plus 2 times x minus 3. Now this one looks a little bit more intimidating, right? I have to FOIL both of these terms. So first I have to take the x and multiply it to x and then minus 1. And so that gives me an x squared minus x. Then I gotta take the 2, multiply it to x and then to minus 1. And that gives me a plus 2x minus 2. And that's equal to, I'm going to do the same thing over here, right? So I have x times x gives me x squared. X times minus 3 is minus 3x. 2 times x is plus 2x. 2 times minus 3 is minus 6. I have x squareds now. That's kind of scary. But they cancel each other out, right? I'm going to subtract x squared over here, subtract x squared over here. Bing, bang. They're gone. Nothing to worry about. So I'm going to go to the next line. I have minus x plus 2x minus 2 equals negative 3x plus 2x minus 6. Okay, now I'm going to gather like terms, solve for x. So I have minus x plus 2x gives me 1x. Let's go to another line actually. Minus x plus 2x gives me 1x minus 2 equals negative 3x plus 2x is a negative x. Then I'm left with minus 6. Add x to both sides, and I get 2x minus 2 equals negative 6. Now, I'm going to bring that to right there. Copy down, 2x minus 2 equals negative 6. If I add 2 to both sides, I get 2x equals minus 4. Divide both sides by 2, and I get x equals negative 2. Kind of ran out of room right there, sorry about that. Right, now if I take negative 2 into here, or negative 2, plug it back into my equation, I should get the same number on both sides, the equal sign. And this is my one unique solution to this equation. And even though it has a quadratic term in it, it turns out to be linear once I subtract out the x squareds from both sides. All right, so this is the last example, and this is one where people might get a little freaked out. So let's look at this one right here. So I've got x plus 2 over 4 plus x minus 5 over 3 equals 2/3. Oh, we got some fractions going on, right? These fractions suck. Nobody likes fractions. Everyone hates fractions. So what can we do to get rid of them? Well, first, let's find the LCD. The least common divisor is the LCD. So, or it's the least common denominator. Sorry, not divisor. Least common denominator. Okay, well, we want to find the smallest number that is a multiple of 3 and 4. And that number is going to be 12. So now I'm going to take this LCD and multiply both sides of the equation by it like this. So I have 12 times x plus 2 over 4 plus x minus 5 over 3 equals 12 times 2 over 3. Now, I take this 12 and I have to distribute inside of here, right? That's how distribution works. So I'm going to get 12 times x plus 2. And remember, this is a 12 over 1, right? Let's write that. And when I'm multiplying fractions, I multiply straight across the line, right? So I have 12 times all of x plus 2 over 1 times 4. So this gives me a 12 times x plus 2 over 4 plus 12 times x minus 5 over 3 equals 12 times 2 over 3. Now, 12 over 4 reduces to give me a 3 times x plus 2 plus 12 over 3 reduces to give me a 4 times x minus 5. And then over here, 12 over 3 reduces to a 4 times 2. And now this looks not too bad, right? I do what I did similarly to the first problem. I'm going to distribute, rearrange, and solve. So now I have to distribute inside of here, and I get a 3x plus 6 plus 4x minus 20 equals 4 times 2 is 8. Gather like terms. I have a 7x minus 14 equals 8. If I add 14 to both sides, I'm going to go over here. I'm going to get 7x equals 22. Divide both sides by 7, I get x equals 22 over 7. And just a fun fact, 22 over 7 is actually an approximation of pi. This is approximately equal to pi. Nobody needs to know that, but I made the problem up earlier, and look at that, I got a cool result. And okay, well that's all I've got for solving linear equations. I hope you enjoyed this video. Make sure to like and subscribe, show it to your friends. If you have any questions, just leave in the comments. Thanks for watching. Bye.